This video is just going to be a brief recap of how to solve inequalities, and we're also going to look at how to put our answers in set notation, which is going to carry over from our work with equations in Unit 2A. So one of the most important things to remember when we solve inequalities is that we flip the sign anytime we multiply or divide by a -1, or by a negative number in general. So if we look at this example, we know that 2 is greater than 1. So if I were to set 2 and 1 on a seesaw here, 2 is greater, so it's going to balance down. But if I multiply both sides of that seesaw by -1, now my balance is shifted. Even though 2 is a larger number, when we make it negative, it's further away from 0, so its value is actually less than that of -1. In order to correct the balance, we have to flip the inequality symbol around to reflect this change. And that's why anytime we multiply or divide on both sides of an inequality by a negative number, we have to flip the sign in the middle. So, remember that we solve inequalities the same way as we solve equations. So I look for my variable, I think about what I need to do to isolate that variable. So here I'm going to multiply by 6 on both sides. And we'll get x is greater than or equal to -42. I multiplied by +6, so my sign stays the same for my inequality. Now, for set notation, we start with our inequality. And we're defining the values of x such that x is greater than or equal to -42. So it's very similar to what we did before with equations. We have the x, we have the divider, and then we have our rule. Next, we want to circle possible solutions. So my answer said that x is greater than or equal to -42. So I want to circle any numbers that works for. So -120 and -43 are not greater than or equal to -42, but 7, -41, and 43 are all greater. Because we have the or equal to, we can also include the -42. If we look at the next one, we have -4 times k is greater than 16. So in order to isolate k, I'm going to divide by -4. And because I divided by a negative, I know that I have to flip my inequality symbol around. So we have -4 on the right-hand side and k on the left-hand side. So our set notation is going to be the values of k such that k is less than -4. And now we circle any possible solutions. -10 is less than -4, -6 is. Because it's strictly less than, -4 is not a possible solution. We can't say that -4 is less than -4 because they're the same value, so that doesn't work. And then obviously all of these numbers down here are greater. If we look at our last example here, we have 3 minus x is greater than or equal to 8. So my first step, I'm going to move that 3 over. So we have x is greater than or equal to 5. And now we have -x is greater than or equal to 5. So I'm going to divide both sides by -1. And when we do that, we have to flip our inequality symbol around. So we end up with x is less than or equal to -5. And in our set notation, we have x such that x is less than or equal to -5. And then we want to select all of our possible solutions. So -10 and -6 are both less than -5. And because we have the or equal to, we can select -5 as well. In this video, we're going to look at how we graph inequalities on the number line. This is just another way of representing our solution visually instead of numerically like we have in the set notation or just as the basic inequality. The first thing that we want to remember is what these 4 symbols actually mean. And you want to remember that depending on where the variable is placed, we can't have these general rules for what the symbols mean. So we always have to look at where the variable is in relation to the symbol. Our symbol that opens to the left is read as greater than because whatever comes first is greater than whatever comes after that. Okay? So if we look at this inequality on the number line, we have all of the values here that are greater than -5, but we don't include anything that's equal to -5 because we have that open circle. So this inequality is x is greater than -5. If we look at this inequality, it's going off to the left, and as we go further left on the number line, our values get smaller. So this is less than, and we have that open circle on -3, meaning that we don't want to include -3 in our solution set, but we'll take everything right up to -3. So -4.9, negative 3.01, negative 3.001, negative 3.00001. As we get closer and closer to negative 3, we'll take all of those values, but we can't take negative 3 itself. So this is x is less than negative 3. When the variable is on the left-hand side of the expression, or of the inequality, the arrow of the inequality points in the direction of the graph. But this changes if we rewrote this as negative 3 is greater than x. Notice that it doesn't work. So you just want to be careful with kind of those general rules. The directions for greater than or equal to and greater than are the same. We both head off to the right. But now we have this closed circle here. So this represents x is greater than or equal to 2. That closed-in circle means that we are also including that value right where that circle is in our solution set. Same thing with less than or equal to. We're going to the left, so we know it's less than. But we have the or equal to because we have the closed circle here on the negative 2. It means we want to include that value in our solution set. So anytime I want to graph these, I always start at the number on the other side of the inequality. And this is once my variable has been isolated. So here, obviously, we're already given x by itself. I'm going to start at negative 5, and I look to see I have that or equal to. So that means I'm including negative 5, which means I'm going to have a filled-in circle. So we come to negative 5. I usually do it above the number line so you can see the values, but if you do it right on the number line, that's okay. And we want everything greater than negative 5. So we are going to go off to the right. A lot of times your number line is not going to have labels, so if you are given a blank number line or you have to draw your own, usually what I will do, we'll put 0 in the middle, we'll put the number that's in our inequality, so negative 5, and then I'll put its opposite on the other side of 0. Then we just draw in our closed circle, and we go off to the right. So this is what you should do on a worksheet or on homework if your number line doesn't have all these labels. This just gives you some context as to where you are on the number line. For our next one, we have 4 is greater than x. If you're more comfortable, feel free to rewrite this as x is less than 4. Just make sure that whatever side of the inequality is with the variable stays with the variable when you flip it. So we go to 4. This is where we're going to have an open circle because it's strictly less than. And because it's less than, we're going to the left. So we go this way. And we want all those values that are smaller than 4. Again, if our number line didn't have labels, we throw 0 in the middle. We have 4, since that's in our inequality, and then we take its opposite and put it on the other side of 0. We do our open circle, and we go off to the left. In this video, we're going to look at interval notation, which is another way of representing the solution to an inequality. And keep in mind that when we solve equations, our solution was just one specific or two specific numbers. But when we solve an inequality, as we saw when we graph them, we're talking about a whole range of numbers. And an interval is another way that we can express that range of values. We have a couple different symbols that we use when we write interval notation. We have parentheses, brackets, and sometimes we also get to use infinity. So an interval will always have an endpoint and a beginning point. So if I, for example, have 2, 3, this means I start at 2, and I'm taking all the values that go up to 3. The parenthesis means that the endpoint is not included in the solution. So if I see a parenthesis, that means that I'm going to have an open circle if I graph, and it could be a less than or a greater than symbol. If I see a bracket, this means that the endpoint is included in my solution. So here we have the filled in circle, which means we have less than or equal to or greater than or equal to. For right now, we're going to be looking at intervals that extend forever in either the positive or the negative direction. So we're going to incorporate infinity in our interval to indicate that those numbers keep going. We keep adding values into that solution set. A little bit later on, when we look at compound inequalities, we'll look at intervals like this one, where we have two specific starting and end points. And I think it helps to look at the graph of these inequalities when we put the intervals together. So if I have x is less than or equal to 5, we can graph this on the number line. So we've got 0 in the middle, 5, and its opposite. I have that or equal to, so we know this is going to be a closed-in circle, and I want everything less than or equal to 5, so we're going to come off to the left. If it helps, you can show where negative infinity and positive infinity would be on your number line. Obviously, positive infinity is off to the right with the positive values. You don't need to write the plus sign there. And negative infinity is off to the left with the negative values. I look and I see which way my graph is facing. My graph is pointing down towards negative infinity because my values keep getting smaller and smaller and smaller. So I'm taking negative infinity in my interval, and I want everything up to 5. Now we go back to our inequality. Because we have that or equal to and that closed circle, this means that 5 is included in our solution. So I'm going to put a bracket on there. The bracket kind of squares up and latches onto the solution, keeping it in the solution set. Now, infinity itself isn't really a number, it's more a concept that we keep going further and further in that direction, so I can't put a bracket to latch onto that specific value. Instead, we put a parenthesis. Infinity and positive or negative infinity always get parentheses around them. We will never put a bracket on there. So the interval for this specific inequality is negative infinity to positive 5. If we look at our second one, we have y is greater than negative 2. So if we visualize this on the number line, we've got negative 2, we've got 0, we've got positive 2. Because it's strictly greater than, we have an open circle, and we want all the values larger. So 0 and 2 are larger than negative 2, so we come off this way. We can put negative infinity and positive infinity on there just to kind of help us see where we're at. So we have negative infinity on the left-hand side and positive infinity on the right. Now we need to think about my interval. If we look, we see that our graph is headed off in the positive direction, meaning we keep adding those values to our solution set. So we're going to have positive infinity. But we start at negative 2. We always read our intervals left to right, start to finish. I should be able to take my interval, place it on the number line, and have those values be in the correct option, in the correct space. So if I take this and I write it, I have negative 2, positive infinity, infinity's on the right, and negative 2 is on the left. It wouldn't make sense to have infinity here and negative 2, because positive infinity is not smaller than negative 2. This is a positive value, these are negatives, so this does not work. Then we look at our open circle. We have strictly greater than, so this is a parenthesis, and infinity always has a parenthesis attached to it. This works the same even if our inequality is written kind of backwards. We can rewrite it as a is greater than or equal to 3. So we can think about this one if you want to try it without the graph. We know that we're taking all the values that are equal to 3 and higher. So we start with 3 and we're going to positive infinity. Because we have the greater than or equal to, we put the bracket, and then infinity always gets a parenthesis. If we start with y is less than 0, this means that we want all the values that are smaller than 0. As soon as my variable is less than a number, I start with negative infinity, and we go all the way up to 0. Because it's strictly less than 0, we have a parenthesis, and then another parenthesis on negative infinity. Another question that you might see is where you're given an interval, and you're asked to reproduce or match the graph. So if we have the interval 4 to infinity, if I start with my number line, I have 0, I'll put 4 and its opposite. I know that I'm going to have a circle on 4. We look, we see a parenthesis next to 4, so it's an open circle. And our next value is infinity, so we're going off to infinity and beyond, if you're a fan of Buzz Lightyear. Likewise, if we have an interval negative infinity to negative 2 with a bracket, we can construct a graph from this as well. So we have 0, we have negative 2, we have positive 2. I can look, I see I'm going to have a circle at negative 2, I have a bracket there, so it's going to be closed, and we want everything less than that down to negative infinity, so we come this way. And we can write inequalities to match these, so this would be x is greater than 4, and here we would have x is less than or equal to negative 2.